All right, good afternoon, everyone, and thank you for coming to what I would say is probably one of the more boring sounding sessions if you look at the title of this thing, but actually I'm really excited. You know, over the last 3 days, you've been hearing about amazing features that we're shipping in AI Foundry, and what this session is really about is how do you get value from those features? In other words, if you're exploring and experimenting and starting out and getting started, it's really easy to do that. But as you all know, it's hard to scale, and it's hard to scale with efficiency and reliability. And so that's what we're going to be focusing on in today's session. Today's session is all about how to operate a scale application workload on AI Foundry that's using the latest generative AI models. Now, hopefully you've heard a lot about AI Foundry this week, and so I don't need to go over what AI Foundry is for you today. You've got all the context on that, and if not, go watch a bunch of the other sessions. But within AI Foundry, what we're going to be using is we're going to be using Azure OpenAI as the core service that we're going to be focusing on and optimizing because it is our biggest scale service today. We have over 70,000 users pushing through trillions and trillions of tokens every single week at scale on the platform. And so what we're going to be sharing with you today is some of the best practices and lessons learned as platform providers and also from a couple of our customers who are here today as well. And we look forward to sharing those with you. We're also going to be announcing and talking about a bunch of new features. And so this is the glimpse of what is coming up in this session. This is what you will get to learn about in detail today. And we're going to unpack all of these in the next 60 minutes. So I hope you brought your seatbelts with you. It's going to be a pretty fast-paced ride. We're going to be talking about Model Router in depth. You've heard our leaders talk about this. We're going to get into the details. How does it actually work? What are the features that you can gain? When would you use it versus picking a model directly? We're going to talk about the new provision throughput that is now fungible, and not only for use within Azure OpenAI, but with models like DeepSeek, and how that's coming in the future too to deliver you more value. We're going to be talking about how to get value out of that provision throughput with features like prompt caching and spillover, and how you can use those to maximize your fleet at scale. And we're going to be talking about some amazing new capabilities within our batch workload that lets you grow to even greater scale. So all of that is coming up in today's session with demonstrations and with customer testimonials as well. First of all, Azure OpenAI as a platform, I'll tell you quite simply, our goal is to be the best model serving platform in the industry. And I'm saying that to all of you so you can hold us accountable towards that goal. And I really mean that. I love jumping on calls every single day of the week with customers like you to understand where are we not the best, and let's become the best. Some of the categories that we do believe we are the best is in reliability. We offer a 3 nines SLA across our entire service. That's not just for provision throughput. That is across our batch service, our standard pay-as-you-go token service, and our provision throughput service. All has 99.9% reliability SLA on it, which means if we don't hit that SLA, you can get money back from us. We have the most number of regions of any other service in the industry as well. 28 regions today. More regions are coming. That means that you have the choice over where your data is stored, where it resides locally, and where it is processed in the different regions of the world. And we're going to get into that detail as well. We have guaranteed throughput with our provision throughput service with a latency SLA. That is guaranteed performance on our provision throughput service. That is the best service that you can buy for your highest scale workloads. And we also have data residency zones for the US and EU. This gives you the flexibility of being able to work across a large distributed area, gives you access to the most capacity, together with the constraints of data processing within European Union member states or within the United States, based on your business needs. And we're bringing all of these capabilities together in the shape of our offering portfolio. Now, we believe we have the most flexible offering portfolio in the industry, offering you different types of services that you can use based on your business needs. And we're going to unpack why would you use these different services. Why would you use the standard service? Why would you use batch? Why would you use provisioned? And hopefully all of you, at least by the end of this session, will get the sense of how you use all of those capabilities based on the life cycle of your application development. And it's not just about the offers, it's also about the locations that those offers run in. Where do you use your deployments in a global? Where do you want to use data zones? And where do you want to use regional? And why would you make that choice as well? And we're going to unpack all of that. And we're going to start with all of this together with our standard service. And so for some of this, I'm actually going to invite Setu to come up on stage as I introduce this. Setu is a PM on my team. Why don't you give him a round of applause as he comes up here? He's going to be setting up for a demo here in a moment that we're going to be showing you. But the first service that we have is our standard service. This is the place for you to get started. You only pay for what you use, standard tokens, right? And yet it's also incredibly high scale and high performance, which means it's not just for development. We see customers scaling through to massive scale on the standard service. It's the easiest to manage because it's available across all of our SKUs, and it's available in every single region that we have as well. So it's ideal for most of the use cases. It's really cost effective to get started, and it's good for most workloads up to high scale. Now, one of the challenges within standard is, OK, all of the models are available in standard. That's great. As you heard, we now have over 10,000 models in our catalog. Some of those are deployed to manage compute. But we have now 5 marquee providers that you can buy standard tokens for. You can buy these for Azure OpenAI. You can buy these for the Grok models from xAI, for the Llama models from Meta, for the Mistral models from our partners in Mistral, and for the BFL models, the Flux models. All of those models are available through the standard offering. That's fantastic. It gives you a lot of choice. But with that choice, I often get the question of, well, how do I choose? Where do I start? And historically, what we found is customers always started with the state of the art, the best model. It's the best way to get started, right? You will be able to prove the technical feasibility of your solution. Then as you begin to scale, you start to optimize. You start to look at, OK, for which tasks can I use a cheaper model? For which tasks can I accomplish the same effective outcome with a lower price? And that's the best way to optimize, but we're pushing all of that on you as the customer to figure out. Well, this is where Model Router comes in, because Model Router actually takes that complexity onto the platform. This is actually a model that we have trained off a whole bunch of sample data, which looks at each individual prompt. And based on the complexity of the prompt and what the prompt is trying to do, it'll serve using the most optimized model. So Setu, do you want to tell us a little bit, how does Model Router actually do this?
Hey, Steve, thank you. All right, so what's a model router, and how does it really route between the various prompts that users provide, right? So the current challenge that users face today is choosing the right LLM for a given task. So for any of the use cases that the people have, users have, there are going to be queries that are going to be simple, and there are going to be queries that are going to be complex. The challenge that users have today is the developers have today is to figure out the right model. And Steve just announced that, like, in the past few weeks, we have announced like everything from 4.0 Nano to O3. So we have Nano, Mini, 4.1, O3, and O4 Mini. How do users select the right model? Users typically tend to stick in one of the other corners, right? They either go, typically they go for 4.1, which is a flagship model, and don't tend to explore the other one. So the question is, how do we allow users to select the right model? And Model Router does that. So the opportunity here is to select to optimize the cost while maintaining the quality by dynamically selecting the best model. And let me explain how the Model Router works. So in this picture, you can actually see 2 models, 2 queries, a simple query and a more complex query. The requests go to a Model Router, and the Model Router now figures out, it's a trained model. It's an AI model that's trained to select, based on the query complexity, which of the underlying models to route to. So in this case, you can see that the simpler model is getting routed to a Nano model, and a more complex query is routed to the Mini model. And you get an optimal response here. And I want to call out that the Model Router talks like chat completions endpoint. So there's nothing different. Okay,
there. So I don't have to do anything within my prompting specifically for the Model Router. As long as I'm calling chat completions, it'll automatically work. Now, what types of models, because you mentioned a bunch of models there, Setu. You mentioned that today, we just announced this last month, GPT 4.1, the fastest growing model we've ever had, phenomenal quality, amazing scale. We've got 4.1 Mini and 4.1 Nano, lower cost, lower quality, but they've got strengths in different things. But then we also have reasoning models. Yeah. So as a developer, do I have to pick whether I'm using the reasoning model or the chat completions model?
No. So that's the value of Model Router. Based on the query complexity, it knows if it needs to go to a reasoning model or a simpler model like 4.0 Nano. So that's the value that it brings.
So can you actually show us how this works, Setu?
Yeah, absolutely. I'm going to switch to the demo here.
Okay, I think we tried to switch, number 4. Yep. Okay, we might need some help from tech on this one because the switcher is not working. All right, well, we've got the tech crew coming up. You guys want to quickly take a look at this? We're going to get this demo machine up and running. So I'm going to pause and do a little bit of a dance. We're going to come back to the model router demo as soon as this is sorted out, and we'll be able to demo that for you. So the model router, as Setu was saying, and he's going to show you in a minute, will automatically route your prompt to the effective model, which will give you the result of taking that complexity of the decision out in terms of which model to use. The next decision you then have is, OK, what deployment type or offering type do I want to use? So standard is the first offering type we just talked about. That's the best to get started. That helps you out when you're initially building your application. Then when your application begins to scale, you've got a key decision point. Do you want to scale on standard, or do you want to scale using provision throughput? We'll hold that thought since the demo machine is up, Setu. You're on.
All right.
You're live. Why don't you show us model router as we go ahead here?
OK. So this is the model catalog. And you can see that model router is right in the model catalog.
OK, so it just shows up like a model in the catalog today.
Yes.
Can customers today that are in the room access model router?
Yes.
Or is it coming soon?
No, it's something that they can access.
It's available today.
Yes.
As I understand, it was released in the catalog today, so you should be able to see it and just should be able to start playing with this. OK.
As you can see, it has got all these models as a part of the model router. Users don't need to create a separate deployment. You can see 4.1 mini, nano, and 04 mini, all are part of this model router. So let's go ahead and deploy this model.
OK. So the first thing that it's going to do is it's going to make sure that those models are available in the region. What about quota? So I'm used to setting quota on each individual model. How do I think about quota with a model router?
So for model router, we're given like a pretty generous quota matching 4.1 mini.
OK, so pretty much the largest quota out of that family of models you're giving to the model router as well.
Yes.
Fantastic.
And you also can configure RAI filters in this. So all the existing functionality of deployments are available in model router.
Just like a normal model. That's
Yes.
fantastic. OK.
So let's play.
Now that I've deployed it, how do I know it's working, Setu?
Yeah, I want to show you 2 things here. Let's use this in the playground.
OK, so I can just pick it as a model router, just like I can pick a model endpoint.
Yes.
Operates in the same way.
So let me ask a simple query and see which model this gets routed to.
OK, so maybe I'm planning a trip somewhere,
Yeah.
and you're going to ask the weather. Where are we going, Setu?
Yeah.
Paris? Paris,
Yes.
I hear. Anyone here from Paris by any chance? No? OK. Well, we can all find out together what the weather's like in Paris at this time of year. Typically begins with, you've covered up with your cursor there, but OK. So simple response, but which model was used to respond to this?
This went to Nano.
OK, that's the cheapest option. I would expect that. Makes a lot of sense. What
Yeah.
if you put something more complex in?
Yeah, I have a more complex query that requires some planning. So I'm asking for a 9-day trip with a specific budget and specific itinerary.
OK.
So in this case, it went to 4.1.
So this is our best planning model today. We see a lot of agents using 4.1 for planning. This would be what I would recommend for you if you're like, hey, I've got a complex planning task. Which model should I use? And the model router has accurately selected that. Now, this is using one-off prompts. If I actually want to test this for an application, though, the playground is probably not the best place to do that. Can I test this in bulk?
Yeah, absolutely, Steve. So let me quickly show you how this works in a notebook for a data set that the router has never seen. So I have around 1,500 prompts from various benchmarks curated. Let's see how the router compares to 4.1.
OK, so you're just in Jupyter here, and you're running some Python scripts that are going to load a whole bunch of prompts into the router.
Yeah. Right now, I just configured a 4.1 deployment and a model router deployment. I'm going to load the test set. Test sets as around 1,500 queries, and sample prompt looks like this.
OK, so this could be traffic that you've captured as a customer as well within your environment, and we're just running a basic eval of these prompts and responses.
That is right. So in this case, we have a scientific question about hydrolysis, and there is a multiple choice answer, and the ground truth is D for this.
OK.
So now what I'm going to do is for these 1,500 prompts, I'm going to go ahead and run the output, going to create responses for all these 1,500 prompts from both 4.1 and the router.
OK, and this is happening real time. I can see it. This is not a stage pre-baked demo. This is happening right in front of us right now.
Yes.
Fantastic. I love the nervous energy of a live demo. It's always exciting.
Right. So I'm not going to run all the 1500 here to load it, but what I've done is I've successfully loaded I've stored the cache in a pickle file here.
Okay.
So I'm going to run this.
So that saves us a bit of time because it would take a while to process all of those requests. Yep.
Okay. I think the restart is taking time.
Okay. Nothing like a live demo just to have a bit of a temporary pause.
So the good thing is I do have a copy here. So let me open that.
Okay.
So here what's happening is I want to print the a sample output of what we executed right now. The model router, we processed 1500 prompts. Let's see a sample output from 4.1 and sample output from the router for the questions that we asked.
And if I remember, it said before you showed me that the scientific
answer is D.
And so it got that accurate.
Yeah, so 4.1 got it accurate, and model router also got it accurate.
Okay.
And then I also want to compare the quality of responses.
Okay, so now I'm using an evaluator model to actually look at the quality of the responses.
A simple accuracy calculation across both of these, and we can actually see 4.1 is 83%. It's a pretty tough benchmark to call out. And model router is right behind, less than 1 point drop in accuracy.
Okay, so I'm just going to pause on this for a moment and make sure I understand this. When you ran that test set, you were running it against 4.1.
Yes.
And you're running against the model router, which is judging which model I should use, and not randomly, but using the pre-trained model to select which back-end model.
Yes.
Just 4.1, the state-of-the-art model there got 83.1% accuracy.
Yes.
And the model router was less than 1 percentage point less quality.
Yes.
So, okay, I'm going to call that about the same quality. It's a probabilistic model. That's pretty good.
Yes.
So what's the benefit? Am I saving money when I'm using model router?
Yeah, so you can see the cost saving here. So they're around 63% cost saving compared to 4.1 router.
I actually think that's worth a round of applause. I'm just going to... Same quality, 60% plus cost reduction. That's state of the art. That's amazing.
Yeah, and I want to show you, Steve, here you can see the distribution of queries, how we got a cost reduction there. So here you can see this is Azure Monitor, the model router who supports Azure metrics in Azure Monitor.
Fantastic.
You can split
so not
the
only
model
can
name.
I benchmark this, I can also monitor over time while I'm using it in production too.
Yeah, exactly. So here you can see 4.1 mini. The router was able to around, if you compute the numbers, around 73% to 4.1 mini. 04 mini took some of the complex questions and around 13%, and the remaining 10% went to these two.
So that's amazing. So again, as an application developer, if I was going to build this logic into my application, I would have to figure out those 71% of queries that are best served with Mini, those roughly 5% of queries that are best served with Mini, 04 Mini, and then the rest that are between Nano and 4.1. And I would have had to done all of that evaluation myself. Most likely, honestly, I wouldn't have done it. I would have just used the expensive model, which would have then cost me 60% more. Well, 40% more. I got a 60% cost reduction, which is just an amazing, amazing result, Setu.
Yes.
Fantastic. Thank you very much, Setu.
Thank you.
All right, and I just want to give a shout out to our tech crew here who's working behind the scenes, live switching slides as well. So thank you so much, tech crew. I really appreciate you. So as these slides are coming back up here, we're going to talk about provisioned throughput. So that was standard, that was model router. That helps you take the load away from having to select the specific models that you're on. I don't have slides up, but you guys can work on that. With provisioned throughput, this is the guaranteed throughput option for you. So when you have a workload that first and foremost you want to ensure the latency is predictable for your end customers, provisioned throughput is the option you want to choose. What I didn't tell you about standard is that standard is in a region where multiple customers are all sharing together, which means that during peak times of day or during peak times of the month, you can get what's called the noisy neighbor scenario, right? Where if you're in a region where lots of people are all running at peak at the same time, your latency could suffer because it's not a latency guaranteed offer. It's only a reliability guaranteed offer. Provisioned throughput is still a shared service, but we have rate limiter controls that ensures that every customer that's on that service has their guaranteed effective throughput. It is a consistent guarantee. And so it does come with a latency SLA as well as a performance SLA. It's also our highest scale offer, and it's the offer that gives you the maximum amount of throughput total available across the platform. And so this is the offering that we recommend that you choose for your production workloads. Now, on the flip side, the provision throughput service is also paid by the hour, unlike the standard service, which is paid by the token, which means if you're not using it, you're paying for it anyway. And so ideally, what you want to do is you want to size that service so it's the exact size of your nominal average workload throughput. So it's always at 80+% utilization. And then, when you're hitting your peaks, you actually want to use something that we call spillover that we're going to tell you about in a moment. Now, in order to get the most out of your provision throughput service, we actually want to be able to go ahead and use a reservation. So while you guys are setting up, it may be easier. Should I just go to the demo machine? Does that work for you?
I think we're having a major malfunction.
We got a malfunction in the background. OK, so I'm going to come back to the demonstration here once it's live, and we'll be able to demo for you how you buy a reservation. Reservations are really important because reservations are the way that you get the price of the provision throughput down. The hourly rate is high. I'll just tell you that. It's between $1 and $2 an hour per PTU. An average workload might be 50 PTUs, for example, for a high-scale production workload. So you do the math, $100 an hour. That's really expensive. But you can get up to a 70% cost reduction on that by buying a reservation. Reservations are available in a 1-month reservation, which equates to, I think, about a 40 to 50% cost reduction, or a 1-year reservation, which is up to a 70% cost reduction on that request. And so you definitely want to be buying a reservation. Now, there's one more key thing I want you to take away from this. The reservation itself is not a capacity reservation. It's a price saving, right? So the first thing you want to do is to go and deploy your provision throughput. Make sure you've got the capacity. Immediately after that, you want to go and buy your reservation to bring the price down. Make sure you do it in that order. If you buy your reservation first and you don't have capacity, we do have a way to exchange it, but it's an additional headache that you don't want to have to work through from that perspective. I was going to demo, when the machine comes live, that whole process for you. We'll see if that comes up here in just a minute. Oh, we got the slides. Hey, let's give these guys a round of applause for the slides. Now, the question is, if I try and switch to a demo machine, am I going to break this? Let's try number 4.
No, we're going to switch it right.
You're going to switch it there. Manual switching. OK, you guys are amazing. I will call you up every time I need to switch machines. OK, yep, looks like we're up and running. Can you all see the screen up there, the demo machine? OK, yeah, let's give them a round of applause. They're doing the hard work on this one. Thank you, guys. I really appreciate it. OK, so like I said, I'm going to show you a couple things in here. Setu was in here. This is our model catalog before. And so how do I go ahead and create a provision throughput deployment? I'm going to just use 4.0 as an example, because I know I have quota for 4.0 within this area. And I'm going to go ahead and say I want to use this model. Now, remember, we've got 3 different deployment types: standard, batch, and provision throughput. And then we also have different deployment regions. So our global service is the service that, first of all, your data will always be stored in the region of your resource. For me, you can see that's West US. So regardless which service I'm choosing, my data is always stored in the West US. Azure OpenAI is a stateless service. So it's just data processing. There's no storage out of West US, only in West US. The second then is, where is it processed? So with global, it could be processed anywhere in the world, by the definition. With data zone, it will be processed in the data zone. Now, which data zone? Well, I'm in the US, so it'll be the US data zone. If I happen to be in Sweden with this resource, it would be in the European Union data zone. So it's based on where your data is, because that's the promise of the data zone. And then I've got regional, right, which is 28 different regions in the world. If I were to choose to do a regional deployment here, it would go to those 28 regions. So provision throughput, I'm going to choose it. The next question is, well, how many PTUs do I need? Well, the best way to figure out how many PTUs you need is actually over in the quota tab. So all I did is I just jumped into the Management Center quota tab, and I have this great capacity calculator. And within this capacity calculator, it's pre-programmed for a bunch of models. And I'm going to choose 4.0. And it's actually pre-programmed with a bunch of workloads. I could put my own workload inputs into this, but I'm just going to say it's a simple workload where I've got RAG, I've got a basic chat and a summarization. And you can see it's going to actually calculate here that I need about 50 PTUs for that workload. Okay? You can also, as I said, put in your own data into all of this, and it will calculate for you. So if I go back here, I'm going to say, OK, right now I'm in a global deployment. With a global deployment, the minimum number of PTUs is 15. If I were in a regional deployment, that would be 50. Something to keep in mind, there's a difference there. And the step function, in other words, I can step in a global deployment by 5 PTUs. So how many did I say before? 50. Thank you, audience. You were paying attention. I really appreciate that. So I could go ahead, confirm pricing, and buy. Now, I actually bought this one earlier, so I'm going to go ahead and jump over, and we will see that if I go back out of this calculator into my quota screen, come on. What do we think? Was it good today? I'm going to give it a 5. Let's give that feedback to the team. Okay. Yeah, you can contact me back. All right. Your feedback is really important to us. Please make sure whenever you see one of those dialogues, you send your feedback to us. I really do mean that. I was about to show you the quota screen, though, so let me go into this. This is going to take a moment to load because this subscription that I have, as you can see, is called Enterprise Bug Bash. It's actually the subscription that I use within my service to bug bash a bunch of quota, and so I've got hundreds and hundreds of deployments. And you can see I've got 2 deployments there. Well, hold on a second. I've got how many deployments? 2. So I pre-created this earlier, and you'll see that now our provision throughput service is also available for DeepSeek models. All right, my handy, helpful tech crew, if I need to switch back to my PowerPoint machine, can you help me with that, or can I do it? Tech crew? Tech crew? Checking. If I want to go back to PowerPoint? They're coming up here. Awesome. Thank you very much, crew. So we're going to jump over to the PowerPoint because I'm going to show you now how do you buy a reservation in a quick demo. Now, this is pre-recorded. The reason it's pre-recorded, I hate to do this at Build, I know, is because I'm actually showing you screens that don't yet exist. These are Figma mock-ups that actually came out of our UX team because we're building this right now, and this is going to go live on June 1st. So the screens that you're about to see don't actually exist in production today, but I'm going to talk through them and show you what they look like because we're literally building them right now. So let me start with this. The first thing that we're going to walk through here on the screen is how do you actually buy a reservation? Now, you can buy a reservation today. This is not new, just in case you're wondering. What is new is that the type of reservation that we're about to buy is the new Azure AI Foundry Provision Throughput Reservation. If you were to go there right now and you were to buy a reservation, you'd see Azure OpenAI as the only type of reservation you could buy. So the first things that you saw within this demo, if I can just pause it here just really quickly, is that it first selected the scope of the reservation. The scope is this shared across your whole organization? Is this for a specific subscription, or is it for a specific resource? That's your choice. As the customer, you can choose whether you want to share this reservation or not. The next thing is which region does the reservation apply? Your reservation is region bound. So it is flexible across different models, but it is specific to the region of your choice. So let's go ahead and continue that. And it's going to go ahead and select the type of reservation. Again, it has to match the deployment type. So global versus data zone versus regional. And it's going to go ahead and select that. You've got the choice of auto-renewing that based on the period. This is a 1-month reservation. And then you want to make sure the quantity is the same as your deployment quantity. One reservation can cover multiple deployments. So in that region, if I had 6 deployments of different models, you just saw before I had DeepSeek and I had 4.0, I could actually make this reservation for 150 BTUs, and it would cover both the DeepSeek and the 4.0 deployments that I have. Does that make sense? All right. Really quickly, as we go on, what happens if you make a mistake, though? So historically, if you made a mistake when you were setting up your reservation, what you'd have to do is get on the call with Microsoft support and raise a support request to be able to cancel that reservation. It was very painful. It took a long time. And in the meantime, you're paying the bill before you get the refund. Well, we made it a lot easier now with an automatic exchange program. So if you do decide, like, hey, I just bought a reservation for 4.0, but now 4.1's available. And 4.1's not in my region yet. Maybe it's not in West US. Maybe it's over in East US. What do? Do I just sit there and wait until it's available, or can I go ahead and deploy in East US and exchange my reservation? Yes, you can do the latter. And so you go back into your reservation tool, which is an Azure portal, and you choose, hey, let me go ahead and exchange my reservation, select the reservation from the list, and then I can change the region, I can change the amount, I can change the deployment type. I can change any of those within the reservation. And so it's a exchange, and I can even save cost. So it's not just a dollar for dollar exchange. In this example, you'll see that they're actually exchanging a, I think it's a regional reservation for a data zone reservation. Oh, no, sorry, it's a 1-month to a 12-month. And so they're actually going to save money. The price comes down. And so you can make that exchange as you go as well. So as much as we're asking for that reservation to bring the price down, it is something that you can exchange as you go through it too. And so that gives you a lot of flexibility as the customer. I know we ran through that. So once you have those deployments and provision throughput, how then do you optimize those for your production workloads? And so I'm going to invite Saloni on stage with me. She's a principal program manager in the Azure OpenAI team. And she's going to talk us through how do you optimize the deployments to get the maximum throughput with Azure OpenAI. So welcome, Saloni.
Thank you, Steve.
Thank you very much.
Everyone. So I wanted to start with prompt caching. So far, notice the theme. Steve's been talking about price. Steve's been talking about performance. And a little bit of observability, if I were to add to this, would help us optimize our workloads. So Steve, what I'm going to do is talk a little bit about what this feature is. It allows us essentially to, if you have a very long prompt, what you're going to do is we automatically enable prompt caching for you. What happens is it does the pre-computation, reads from the cache, so it fetches from the cache. If it's in the cache, you'll get a hit. If it's a hit, then you reduce the latency on your requests, but also you save costs. And if you don't find in the cache, then the processing will happen real time. You will process the request, but also it will be stored in cache for a subsequent request. So you get to reap the benefits on the next go around.
So just so I understand that, Saloni, so KV cache is an inherent part of every GPU architecture.
That's right.
And it's basically where it stores this internal processing memory. And so what we're doing is we're passing the benefits of that local storage over to the customers.
Exactly. So this is, like you said, it's a function of the GPU memory. And as a platform optimization, we built it internally, and we thought, why would we not pass this benefit on to the customers? So this is a perfect way of you not having to do anything. This is automatic. If your prompt is 124 tokens or larger, this automatically gets, you get the benefit automatically. What also happens is that it stays in your cache for about 5 to 10 minutes, depending on how busy your workload is. And during the off-peak hours, it even stays for longer, for about an hour if you're lucky. So that helps you reduce your costs dramatically, but also help you get the request latency that you've been looking for.
Fantastic. So how do customers make the most of this? Do you have any examples?
Well, why not let the customer code speak for it? Manus is one of our newly onboarded customers to AI Foundry. I don't know how many of you were at Jay's keynote yesterday morning, the day 2 keynote. And so he played the video there about Manus. And they are one of our newly onboarded customers. They call themselves as the self-serving digital assistant. And they are at their core a very AI agent, which does tasks autonomously. What it essentially is a multi-agent architecture and spawns off a bunch of sub-agents. When these sub-agents can do is not just like have to conceptualize this idea, but also break it down into smaller tasks and then run it, orchestrate it, and run it on each of these sub-agents. And these perform complex tasks. You know?
So particularly for agentic workloads, what's interesting here is you end up passing a lot of the same context and over again, don't you? And so that's where the cache hit rate really helps us out.
That's absolutely right. So they are a chat workload at the end of the day, right? But what sets them apart is their constant passing the prompt and larger prompts. A portion of the prompt, which is the prefix, and the large prompts are passed on. And as you can see in that graph, it automatically gave them a very high benefits of prompt caching. They started at about 30%, and then we made some improvements to get them to 70% of prompt caching. And they were able to reap great benefits from a price perspective.
So not only is it faster to use the cache tokens, the other thing is if you're using standard, it's up to 75% off. Is that right?
Yes, so 50% to 75% off for standard. And if you do provisioned, then you're going to be 100% off.
So those cache tokens are 100% free using provision throughput. That's one of the biggest secrets, I would say, that people just don't recognize. This is free throughput for you on provision. It's amazing.
That's right, and we will see it more with the demo and how this cost impact even happens. Another one of the features that we launched earlier this year in public preview is dynamic spillover. This is something that Steve was mentioning earlier. How can you kind of get the benefits of both standard and provision? So imagine that you are on provisioned. I have a particular stable workload that runs on provision, but now I have peaks. If I have peaks, I want to serve it either by increasing my provision throughput and the PTUs that I buy, so now I have to pay consistently for that hour or the month, or I could spill over to that standard deployment for just those peaks. Why not reap the benefits of both? Have that stable workload, run on provision, which is dedicated capacity, and consistent performance. And then when you have those one-off peaks, the bursts, you go on to the standard deployment. And that's where you will get essentially that scaling capability, but with a little bit of latency impact. And so that's how you marry the both and get really the best price performance for your workload.
Awesome. So while the crew is setting up to do our demo here on number 3, let's go ahead and talk about, I think the best way to do this is to show the crew.
Yes.
So as we're setting this
this
up,
is
do
fast.
you want to talk a little bit about the demo setup and
Yeah.
what we're about to show here, Saloni?
Yeah, so while it loads, the setup is essentially, as you can imagine, a very common workload is there are lots of documents that you have to comb through in cases of, say, you have a lot of contracts. And if you have a lot of contracts, then you basically want to make sure that these contracts are read through thoroughly and you're able to summarize them for someone. Or you have workloads like essentially a lot of documentation and support cases you want to comb through, and then you want to make sure that you are able to go and review the trends and then respond to your support case. So many such workloads would basically mean that now I have a huge prompt, which is context that we are passing on, and then probably a one statement or two statement answer, which is direct answer to that large prompt and question that we provided.
And this is a very common workload that we see
right.
across our customer base. So hopefully it's a scenario that resonates with everyone.
Yeah, Manus definitely did.
Yes. And so let's take a look at, what kind of throughput does a customer get and how do they see with this workload? So what are you doing here, Saloni?
So what I'm doing is essentially I've been basically simulating this workload. What I've done is given it about this whole load test, which is simulating the production workload. It is a consistent workload with about 15,000 input tokens. You also see it's about 100 output tokens. So that's that short output generation that it reveals. At this point, I am going to zoom into, you could see it's about 248 successful requests. It's about 3.7 million tokens per minute. And at that rate, you're ramping up into even your cache matching. So if I zoom into, actually, a couple more things I want to hit, the observability piece, right? If you notice, I'm also trying to see the time to last byte and also about the tokens per second. You see about 100. If I am running on a GPT-4o mini model, if people are familiar with the 4o mini model, the TPS or the SLA for it, for 99% SLA, is essentially 33 TPS. And so I'm pushing it way beyond that, so you're also getting that performance benefit. Now,
and you're able to push through why? How are you able to do that, Saloni?
This is essentially how we are, this is with the prompt caching aspect of it, right?
Amazing.
We are making sure that these computations stay in your cache for longer, and so that you could just directly read from your cache and be able to respond quickly. If I zoom into this cached portion of the workload, you'll notice that the successful requests have climbed up even more, almost double. And you notice I had 3.7 million, now I'm at 6.8 million tokens per minute. Throughput's doubled. And what I'm also going to see is the cost impact. So while this is refreshing, you will notice that the list price is about 1.01 tokens per basically minutely cost. And the generation one is 3 cents. I don't know if I'm going to have luck with switching to the slides.
So can we bring the slides back up as well over here?
But while he brings up the slides, one more thing to note is I am running these PTUs at 100% utilization. So what I'm doing is also making the best use of the PTUs. I am running at great time to last byte as well and still maintaining that high TPS while I'm still doing prompt caching.
So just to summarize, Saloni, what I think I heard there. First of all, you're able to push the model beyond its peak limits by using prompt caching.
That's right.
Secondly, you're also able to maximize your PTU throughput because you've got the benefits of spillover if you actually hit. So normally, if you're using provision, if you're not familiar with it, if you exceed your quota, you exceed your throughput, you'll get rate limited. You'll get throttled down. And that ensures that you're not getting a noisy neighbor on anyone else. But of course, that's not a great experience for your end users, your end customers, because they get retries. And so
right.
this dynamically spills over.
Yeah, so we're going to see a spillover portion if and when the slides come up. But at that same point, one more thing that that I would add is, you're seeing the request latency drop, and then the cost will also come up, come down.
And we've got the slides up now, so this is working. Yep.
Awesome.
Yep. Okay.
And so this is let me show you side by side. This is the cost comparison. Essentially, if I were to run with standard and prompt caching, you see the benefit. We are able to run a 50% cache match, as well as the 50% discount you'd get for 4 Mini, and that comes down to $34K. Whereas with provision, you would have the flat rate, like Steve was saying, $2 an hour or $260 per month, and that would be 24.7K.
That is amazing. And so, Saloni, I'm going to jump us ahead here just for time, because we've lost a little bit with the transition here.
That's
and
okay.
so that is amazing.
Yes.
Thank you very much, and thank you for showing us the value of prompt caching. Thank you, Saloni. So that's theoretically what the platform can do, but I always love to put theory into practice with our customers. And so why don't you all give Sid a huge round of applause from Hilo. Come on up here, Sid. And as he comes up, I hope it's okay. I'm going to save the video for the end because I think we are going to be short on time, and frankly, I'd love us to talk about what you're doing. So give us a brief summary of who Hilo is and what you're building for your customers.
Sure. So we're a healthcare technology company. We're based out of Massachusetts, and our customers are physician offices and payers. And we build software solutions for their patients and for their members. We take the patients through a journey of when they see a doctor, from everything before the visit, during the visit, and after the visit. And just to give you guys a little bit of a picture of the scale, the footprint of our product, we touch about 16,000 physician offices. We processed payments about $2 billion in last year. We have an app which allows patients to access their health information. It's one of the top 5 apps on the medical apps in the App Store. And we also work with the top insurance companies and PBMs.
So that's amazing. So amazing scale of what you're doing here. How have you really harnessed the power of AI within this? What problems are you solving?
Yeah, so Hilo Genie is our newest product that we plan to launch next month. And one of the biggest challenge with healthcare practices is the cost of operations. When patients call the doctor's offices, they're often put on long wait, hold times. And even if they get to talk to someone, they kind of move from one person to the other, often not getting the right answers to the question. Leads to frustration and long wait times and all of those issues. So we've incorporated OpenAI, Azure OpenAI, into our product, and we've created an agent called Hilo Genie, which basically takes patients' requests and processes them and gives them the answer right away. They don't have to hold anymore. If the call needs to be escalated to a person, it escalates the call to the right person. And so it has a built-in contact center solution. It sits on top of a EHR or a CRM tool. And it also assists the agent. So a human agent could take, let's say, anywhere between 3 to 4 minutes, sometimes more, to address a question. With the help of the AI assistants, they don't have to go through different places, different areas of the product, and find information. They get the answer right there on their screen.
That is truly life-changing, especially for someone who may not be feeling well and is just looking for answers or the ability to book and get the right specialist or physician to take care of it.
That is correct.
That's amazing. And so I know that you all chose to build this with Azure OpenAI and on Azure. What does your architecture look like, and why did you choose to use Azure?
Sure. So this gives you a glimpse of what our architecture looks like at a high level. What you see on the screen is a patient coming in. They could be coming in through a voice call. They could be coming in through an SMS request. They could be coming through a chatbot on a website. We use Azure Communication Services to route that information. We use the Function app to take that and send it to the FAST API, which then processes the information, gets information from the data source, and uses OpenAI to get the answer and get that response back to the patient.
Now, we've been talking a lot about different deployment types. What did you choose and why did you choose it?
Well, we've tried for real time. We wanted to reduce the latency. That's key. The experience of the patient is very critical. We use the PTUs because we want the experience of the patient again to be latency free. We want guaranteed response time. So that's critical for a healthcare setting.
I'm sure in healthcare, security is also critical.
Absolutely.
And so, what were the key decisions? Okay, so you've got provision throughput, you've got Azure OpenAI services. What were your decisions for Azure?
Well, we have to be compliant through, from a regulation perspective, HIPAA, PCI, HITRUST, ISOs. It's a highly regulated industry, healthcare, as you know. And we need to make sure that the data is always private. It stays in the country where it needs to be. So here in the US, where we operate, it has to be encrypted at rest as well as at transit. And so, security was paramount, for us to make that decision to use Azure.
That's fantastic. So I love this real-life use case because it shows how technology truly can transform people's lives.
Yes.
And so thank you so much, Sid, for coming on up. And thank you for showing us that use case. Thank you so much. So again, provisioned is the primary use case that you want to use for your predictable, high throughput, high reliability scenario. I think Sid's case and what they're doing at Hilo is a perfect example of that. And now we're going to move on to batch. Now, batch is the service that you can submit a job and have the job run sometime in the next 24 hours. And so this is the kind of case where maybe you need to summarize a bunch of information or prepare for things to happen the next day. And you can use batch, and you can lower your cost of doing so because the cost of serving on batch is actually 50% of the cost of what it takes to serve in a real-time workload. And so I'm actually going to invite two guests on stage at the same time here, which is both Setu, who you saw from before. So coming up, Setu has talked about Model Router. And we're also going to invite Chris from CVS up here, because they're actually going to have a conversation with you about, first of all, what's new in batch. And then we're going to talk about how you're using batch, Chris, to transform the healthcare space. So Setu, I will ask, I know we've got a demo. Let's save the demo for after the customer conversation, just for time. So with that, Setu, first of all, why don't you tell us what's new in batch?
Yeah, so what's new in batch is we are announcing this large-scale workload support in batch. So till now, customers run batch for 24-hour workload. They use a quota, NQ token capacity, for example, of 10 billion tokens and then execute it. But one of the key asks from customer is, hey, I've got a large customer workload, like similar to what CVS is going to talk about, large workload, billions of tokens, but I want to execute this in over a weekend or in over a few days. How do we do that? And these are the 4 new features that we are kind of announcing for build. One is dynamic quota. This lets you queue tokens more than your quota. If you have a quota of 10 billion, this can, as much as the system capacity is available opportunistically, is going to be able to queue tokens and execute. Second thing is a 10,000 file upload limit. So currently we have file upload limit of 500 files. Now with the file expiry feature, you are able to upload up to 10,000 files and queue up and run. These were 2 of the biggest bottlenecks in running large-scale workloads. One was token capacity bottleneck, and the second was file limit. So both we are unblocking. And the third thing is interesting because you don't need to upload files. Some customers who are Azure customers who have Azure Blob Storage, were wondering, why do I need to upload and download files? With Bring Your Own Blob, you directly point your input file to when you submit a job, and the output is written again to the blob, so you don't need to go through the files at all. And finally, one of the most asked features is the smarter programming constructs to queue up jobs. So today, queuing, if let's say you've got like 100 billion tokens that you want to queue, it's pretty challenging the way you queue and dequeue the output files. With the smarter programming construct, you just have a simple while loop that you can use to queue the jobs, and you'll get a fail fast as long as immediately when you upload a file, when you queue a job, you will know if you have a token limit exceeded, and you can do an exponential back off and keep queuing again. So those are the 4 new features that we have. It's going to help you unblock, run large-scale workloads in batch. So I'm really excited to invite Chris Schubert from CVS to talk about their large-scale workload in batch. And it's a truly inspiring application that they have that literally saves people's lives and extend patient outcomes. So over to you, Chris.
Thank you. I'm Christopher Schubert, Executive Director of Machine Learning Engineering at CVS Health. I'm here to talk today about how we are transforming unstructured patient information into actionable insights that clinicians can use to both understand a patient's history and take clinical action to improve patient outcomes. So you may know CVS Health from our retail pharmacies. We have 9,000 locations around the country, but there's also our specialty pharmacy, infusion services, our healthcare and pharmacy benefits, and then the focus of our talk today is really healthcare delivery services. In-home care, we'll do over 3 million home visits this year, as well as over 1,000 locations of primary care and walk-in clinics. So really the reach of CVS Health is unmatched. This gives us an opportunity to engage with over 100 million consumers to deliver high quality, affordable, and personalized healthcare when and how they need it. It also creates for a very impactful opportunity to do great work with software, machine learning, and AI to solve complex problems at a massive scale. One of those problems is that every day in healthcare systems across the country, clinicians are overwhelmed with the amount of clinical information they have to evaluate for a patient. If you think about the vast amount of structured data that exists within our healthcare system, imagine also then that CVS Health receives many millions of clinical documents every day. Faxes, scans, clinical notes, medical imaging. Now, a single piece of critical patient information, something like a prescribed medication or a medical procedure that happened, a past diagnosis, or a lab value that is trending in the wrong direction, might exist in a single clinical document. And that might be a low-quality image or a scan of a fax. So you can imagine the complexity. The sum of a single patient's unstructured data can be anywhere in between a Great Gatsby all the way to The Return of the King. It's impossible for a clinician to evaluate that volume of information before a visit. Consider then that a physician has between, in a clinic setting, 12 to 15 patients to evaluate in a day. So really, the result is that in healthcare systems that cannot account for this complexity, there is an opportunity for critical patient information to go unnoticed. And that creates a blind spot in patient care. At CVS Health, we have a clinical insights engine that helps provide our clinicians with more accurate and complete understandings of our patient's history. It locates and extracts phrases, numbers, ranges, and more from a patient's unstructured medical information, searching exactly for what a physician would. Once extracted, that information can then be evaluated against physician-defined logic to generate insights that are structured, auditable, and traceable back to the source documentation, which is critical. The engine leverages prompts that are developed with interdisciplinary expertise. So we have physicians collaborating on prompt engineering with scientists and engineers and informaticists. An example of what we would look for would be in a cardiology note, left ventricular ejection fraction or aortic valve obstruction. Now, with the ejection fraction in particular, and that's a measure that indicates how effectively your heart is pumping blood, if we find that that value is between 35 and 45%, it's critical that we get that flagged and in front of a physician, because that value represents a key characteristic of something that we would consider to be heart disease. And so if that's not managed quickly, that can progress to congestive heart failure. So the point of the engine is making sure that we have a more complete and accurate view of the patient, and we can get in front of the clinician so they can take clinical action to improve outcomes for people.
So Chris, you mentioned in our discussion that batch is in fact was faster than online. So can you kind of set up the problem on specifically around the LLMs and how you compared online batch and how it was useful for your application?
Absolutely. So we really, we had I think Steve earlier mentioned, demo is great, easy, fun, happy. Scale is very challenging. And so we had a very effective first delivery of our system. It was highly accurate. We went through multiple rounds of clinical review on prompts and responses, and everything looked very good. Now, we were calling standard deployment, pay as you go, and as our volume increased, we started to have issues with throughput, quota restrictions, 429s. And realistically, we were facing probably a 15 to 20x scale in our future. So we had new business partners buying in. We had documents by the day arriving, millions of documents a day. And the effectiveness of the system was so exciting for people that we actually had 4 different clinical teams spin up development efforts to build new prompts. So we're in trouble if we can't figure out the scaling problem. Basically, the challenge that was in front of us was, this is a sliver of our document backlog, but 17 million requests, 75 billion tokens. We were looking at 100 days and over $300,000 to process this. And that
I recall you were saying that you need to process this within a week.
Yes, under a week. And so the only thing I could think to do was call Setu. And so that was really when we started exploring the batch API. Now, what was incredible for us is we could use a US-only data zone batch deployment. So it was CVS Health compliant. And as Sid mentioned earlier, there is nothing more important than securing a patient's protected health information. And so that was critical for us. But what was incredibly surprising for me was once the team graciously got us the dynamic quota, which really was effectively unlimited, pushed up the file upload limits, what we could do was take our 17 million requests and split them out across a few thousand files and submit them as fast as we could generate them. And long story short, we got through that entire backlog of 75 billion tokens in just under 3 days. And when the dust settled, our costs were just over $100,000. So that was a huge win.
Thank you.
Yeah. It's very rare that as an engineer you can make one change that both improves your speed and reduces your cost. So that was awesome and really great work by the Batch API team.
Thank you, Chris. And I recall that you, from a developer standpoint, you were just able to, in half a day, you queued up all the jobs, and the rest was just monitoring and then downloading the output.
Yep, it was very easy to adopt, and really the impact of getting through that volume is very real. We found instances of significant lung disease, so emphysema. We found a CT scan from early 2024 that had, this is a patient who was unaware of their emphysema. They were actively smoking. And so you instantly have to evaluate, test, and begin smoking cessation counseling. That we had bronchiectasis. I won't go into some of the medical details of what bronchiectasis is, but finding bronchiectasis in a CT scan is one thing. We found it in a cardiology note that was referring to a previous CT scan. And so a physician is not often going to look for that information there. Now, what's important is this patient was being treated for pneumonia, which is an acute infection in your lungs. Bronchiectasis actually increases the risk of complicating factors when you have pneumonia. And so having both of those, us realizing that was a risk factor, resulted in a more aggressive treatment with a different course of antibiotics. Lastly, we found stage B, pre-heart failure. And so this is really finding references to structural damage of the heart in an echocardiogram note. Initiating management of the patient's cardiac risk factors to prevent further damage to the heart and eventual heart failure. And you can think about stage B pre-heart failure as asymptomatic, right? You don't know it's happening. You don't feel different, but your heart performance is actually decreasing. And so being able to detect this early is a really critical thing for us. So across Oak Street Health and Signify Health, 2 CVS Health companies that we've deployed this engine at, since the fall, we've really found over 1 million potential conditions. And this engine, as well as the Batch API, has become a part of how we think about managing the scale of unstructured data and really wrangling it to give our clinicians a chance to understand a more complete and accurate view of patients' history. So thank you, Setu and the team. Batch API really has been a huge help for us.
Thank you so much, Chris.
Fantastic. Thank you, Setu, and thank you, Chris. And so throughout this session, we've talked to you and given you a whirlwind tour of all the various deployment options in your toolkit. And hopefully you've taken away from this how you can leverage those different options, not just one or the other, but actually combine them together to give you the flexibility that you can get with their standard deployments, lets you get started, pay for what you use, scale up. You can then get provision throughput that actually allows you to sustain maximum throughput with latency guarantees. That's the performance guarantee offer for critical workloads where customer service is on the line. And if you were to hit your peaks, you can spill over and actually use the standard. And then when you have workloads that can be run and summarized and returned later, that's where the batch workload comes in. And so I'm just super impressed by the work that both Sid and Chris have done within their organizations. Is just amazing examples of the kind of value that they can unlock with this. And so thank you all for coming today. It's been a whirlwind, and thank you for the tech team for supporting us through this session as well. Thank you very much, everyone.